Hello, I hope everyone's doing well, and I'd just like to share what I consider to be a very elegant formula. We're all familiar with the quadratic formula, or that's the way that's the formula that's used in the curriculum. That's pretty much what we use. But there's another version of it I like to call it. I like to call it the modified quadratic formula, and not that many people know about it. But it's very, very useful, especially when the coefficient of the quadratic term is 1 and the coefficient of the linear term is even. So, maybe another video I'll go into depth as to why it works. But now I just want to show you, the procedure. Now, the difference is, when you use the quadratic formula, excuse me, let me get that like this. When you use the quadratic formula, you want to get it in this form, right? X squared plus 6x plus 8 equals 0. And by the way, I know you could factor this, but I'm just trying to make a point, right? And you could use the quadratic formula, a equals 1, b equals 6, c equals 8, and you get the right answer, absolutely. But for this modified version of the formula, you want to make sure we're subtracting 6x and subtracting 8 from both sides. You actually want to get it in this form. You want to get it in this form. So what I'm going to do is I'm going to write several examples in this form. Here's example 1. Here's example 2. Negative 12x minus 32. I mean, you'll see how elegant this is, and it's kind of neat. I mean, when I first learned this, I was really excited because there's so many people who are so good at math that don't really know about it. It's not difficult to explain why it works, but it just goes to show you, some things are so ingrained that we don't even think twice about it, and that includes the quadratic formula. All right, so yeah, these are nice examples where the linear term, coefficient of the linear term is even, coefficient of the quadratic term is 1. Now watch how simple this is. Watch how simple this is. You simply divide the coefficient of the linear term by 2, so we get negative 3, right? I'm going to do it one step at a time. Negative 6, negative 5. What's half of negative 6? Negative 3, right? Add the plus or minus. Plus or minus, plus or minus, plus or minus. Square root. Now, you want to square this number and attach the constant. Negative 3 times negative 3 is 9 minus 8. This is our answer. Negative 3 plus or minus 1. You want to square it. You get 36 minus 32. You want to square it. You get 25. What's the constant we're going to attach? Oh, minus 24. 9, we're going to attach the 2. Yeah, I mean, you could simplify. You see how much faster it is? Negative 3 plus or minus 1, which is just 1. Negative 6 plus or minus 2, because that's the square root of 4. Negative 5 plus or minus 1, because that's the square root of 1. Negative 3 plus or minus root 7. We have to leave it in that form. So this always works. It's not a trick. There's a reason it makes sense, but I want to save that for another video. So in just a few minutes, I hope you learn this really elegant modified quadratic formula, as I like to call it, and you see how useful it is. Now, I'm not going to lie. If the coefficient of the linear term is not even, it becomes a little bit more difficult, but it still works, so let's just do one more example. X squared equals negative 7x minus 12. Right? So, negative 7 plus or minus the square root of, sorry, we have to cut it in half. Negative 7 half. So you want to square this. You get 49 over 4, right? Minus, now, we have to attach the constant, but you want to get a common denominator. So here's the difference, negative 7 half plus or minus the square root of 1 over 4. What times what is 1 over 4? And the answer is 1 half, so we get negative 7 halves plus or minus 1 half. And there we have it, right? What's negative 7 halves? So we get either negative 8 halves or we get negative 6 halves. Negative 4. Yeah, and I mean, I would factor it if I had the choice, but I want to show you that it always, always, always works. In fact, it even works when the coefficient of the quadratic term is not 1. You just have to divide by that number. Okay, so it always works. In this case, is it a better choice to use the traditional quadratic formula? I don't know. I mean, it depends on how comfortable you are with fractions. I mean, this is a very, very, very simple thing to follow, though. You just take half of this, plus or minus the square root, then you square it and attach the constant. It's that simple, you know? So, you know, maybe you're more comfortable with decimals. That would also work. So, I just want to make the point that this is a perfectly viable method to use, and it always works as long as you do the math right.